All right, everyone, I'm JJ. Let's tackle an example problem. We have our object shown here is fixed at A, then we have a cable that's also holding it up. Let's determine the support reaction, what's going on here at A, if our tension in the cable is known to be 2 kips. So we're going to have to apply equilibrium to tackle this. If we're doing equilibrium, we have to have a free body diagram. So let's start with a free body diagram. If we're doing that, let's circle around this, freeing it from its supports. So we're going to have to, we'll start right here. We're going to cut through that support at A. We're going to start going down and around everything. As I come up and around the top of this, I can't get back to A without passing through my cable. So I'm going to have to cut it right here as I come down. And then I have to cut it one more time as I leave this. So coming this direction, I also have to cut that cable. So it's going to show up in here twice. It's the same tension, 2 kips, because it's the same cable. It just went around a pulley. That won't change the tension for us, though. So let's come down below and draw our free body diagram. That'll be our first step in here. We have an object that kind of just looks loosely like this. I know at the bottom right corner, I have 4 kips going straight down. 4 kips. At the top, I have my cable. I cut through that. I should always show cables in tension. So I'm going to show it leaving my circle. It has to go to the left. That tension T is 2 kips. T equals 2 kips. If I go to the left from the bottom right corner, 4.5 feet, 4.5 feet, I'm going to get to the cable again. It comes out of there at a 60-degree angle. T still equals 2 kips, but now it's oriented at a 60-degree angle. Also, my height from the bottom to the top, T, is 2.5 feet. So we can label that. Finally, the last thing I need from the bottom cable to the left edge to A, I know it's 2 feet. That's given to us, 2 feet. So I can come in here and say, well, what do I need at A? I know I have a fixed support for this. A fixed support always resists forces in the X direction, the Y direction, and moment. So let's get those in here. I'm going to guess AX goes to the right. AX. I'm going to guess AY goes straight up. AY goes up. And the one that everyone tends to forget or do wrong on this is I need a variable that I am actually resisting here. I have to put in here a couple moment. It's unknown. It's due to the fixed support at A. So let's call this MA. 3 unknowns there at A. I have 3 equilibrium equations. I can find all of those. Don't forget your fixed support resist moment. You're going to start getting marked down more and more, I guarantee you, in your classes as you forget that more and more and more. But let's come in and just find all of those. If I sum forces in the X, AX is my only unknown. So let's start there. Summing forces in the X direction. I have AX. I guessed that it went to the right. I have the X component of one of my cables. It's pointing to the right, so plus 2 cosine 60 minus this cable, minus 2 equals 0. I'm moving everything to the other side and solving for AX. I'm going to get that AX is 2, or just 1 kip. 1 kip. And it's going to the right. I get a positive number out from this, so my free body diagram, I assume the correct direction. That will be my first answer. From here, I have 1 unknown in the Y direction. Let's sum forces in the Y. Summing forces in the Y direction. I have AY going up. I have T going up here, so plus 2 sine 60. And I have 4 coming down over here. Minus 4 equals 0. AY is my only unknown here. I should be able to solve and get from this one that AY is 2.67 kips. That's going up, or I get a positive answer out here. So I am acting upwards. My free body diagram assume the correct direction, and I know that because my equilibrium equation solves to give me a positive number. So I put a up arrow on that to get magnitude and direction shown in there. And then finally, my last unknown, I need MA as well. I can come in and say with positive going counterclockwise, I could sum my moments up about any point I wanted to because MA will show up no matter where I look in here. A couple moment, the location doesn't matter when I'm finding my support reactions. I don't multiply by distance for it. No matter where I sum moments up, it's on this free body diagram. It has to be included in here. I'm going to sum moments about point A to get us there. That means I have to include MA in here. That's a variable for us. It is causing rotation about point A, but I don't need to multiply by distance on here. No matter where I put it, I wouldn't multiply by distance. But I don't include AX and AY in here. Again, notice as I'm setting this up, my first piece in here, this sum of the moments at A, this is just documenting what equation am I working with. This one right here is saying there's a variable that I'm solving for. What's my moment that the fixed support is resisting? I have to have both of those things in there or I'm not getting a full equilibrium equation. I get the right magnitude for my answer for MA, but I'd have the wrong direction on it. That has to be in there as a variable. Otherwise, we really don't have a coherent equilibrium statement. But MA, then I can come in and say, well, my T right here, the Y component will cause rotation. So plus T is 2 to get the Y component, sine 60. That's the force in the Y, so I need an X distance times 2. Force times distance. The X component there would pass right through A. We'll leave it off. Up at the top, I have another 2-kip cable. It's the same cable, another time that it shows up. It would also cause a counterclockwise rotation. So I'll add this in. Plus 2 times my vertical distance here, 2.5. Plus 2 times 2.5. And then finally, my 4-kip force is going to cause a clockwise rotation. So I'll subtract it out. Minus my force is 4. And my distance is 4.5 plus 2, 6.5 times 6.5, which is going to get me, that's everything causing moment. This equals 0. Again, conceptually, if I leave MA off in this, 2 sine 60 times 2 plus 2 times 2.5 minus 4 times 6.5 does not equal 0. Without MA in here, I don't have a valid equation set up. I have to have my variable I'm actually solving for so I can set it equal to 0, solve for that unknown. But we do have that, so let's go ahead and find it. We should get that my moment that's being resisted at A, MA, is 17.54 kip feet. Kip feet going counterclockwise, which would be my final answer. I know it's going counterclockwise because when I solve this equation for MA, I get a positive number out. That means I assume the correct direction up above. Fixed supports keep showing up. When we hit mechanics and materials, my students who are doing not leaving or leave MA off, I mark them down very harshly. It's a fundamental mistake for people to be making. That has to show up as a variable in here. Let's cut that off now if we're struggling with it. Get that sorted out. One of these is what equation I'm working with. One is what's the variable that I'm finding. They should both show up if I'm summing moments a day, though. But hopefully this was useful for you. If it was, hit those like and subscribe buttons. Let's get you an A with JJ.